Okay, I built a parametric diagram and a requirement diagram in UAF to do an analysis of the clearances between the payload and the payload fairing. And it's here's the requirement from the sys, here's the varid requirement. Um, the constraint expression is a straight arithmetic calculation. Basically, the payload fairing to payload clearance measurement, which is down here, is the payload fairing hardware nominal position minus the payload's nominal position minus the payload's manufacturing tolerance minus the payload's dynamic deflection minus the payload fairing's dynamic deflection minus the payload fairing's thermal deflection and the payload fairing's manufacturing tolerance. So there's what I did initially was I built a simulation configuration that just targeted a instance table, and this instance table is here, and the data that you see I read in from an Excel file, and it calculated the payload fairing to payload clearance. I have nominal values in here as 1.655 inches, which, because it's greater than or equal to 1 inch, it meets the requirement. It's true. But what I did was I added, if I'll go back to the simulation execution, I added another simulation configuration because I wanted to do a Monte Carlo analysis. What I wanted to do is to take two of the measurements and make them random variables. So what I did was I took the payload manufacturing tolerance and the payload dynamic deflection, and I added another applied stereotype. So if I open up the specification window here, you can see that the applied stereotype is both the measurement itself as well as a normal distribution. And in this case, the normal distribution, the mean is 0.015 and the standard deviation is 0.002. That's for the payload manufacturing tolerance. And for the payload dynamic deflection, it's also normally distributed with a mean of 0.8 and a standard deviation of 0.35 inches. Now I had to do this in the logical data model library because these are read-only values. So I had to go in there and do that. So for this analysis, you can't use instances, unfortunately. There may be a way around that, but I had to go into the library and put in default values, as you can see here, for all the other variables, and then add the random variables. What I also wanted to do was I added even though I have a constraint here, which defines a Boolean variable here, or value, that basically, if you do the straight simulation on the instance table, it either meets the requirement or it doesn't meet the requirement. But in this case, what I did was I added another constraint called result constraint that simply says payload fairing to payload clearance, that's the variable, has got to be greater than or equal to 1. And so I set up the simulation execution. The execution target is the capability configuration, and as a number of runs, 1,000. Over here, I created a histogram that represents the capability configuration, and the value that I'm interested in capturing is the clearance. And because I have that constraint, it should tell me what percent are out of spec. So let me go up here to the drop-down menu, and I'll hit the payload clearance envelope clearance Monte Carlo and run the simulation. And as you can see, it's running, and here you can see the out of spec building up. So the mean is at what we would expect, around 1.6667, and the standard deviation as the sum of the two random variables plus the other deterministic variables. But you can see that we're building up a certain percentage of them that are out of spec. Um, and it's got about 200 more runs to go. There's one, so most of them are greater than or equal to one. So now we've got the results. You can see that basically 2.5% were out of spec, or 0.025. And you can actually, and because what I did was on this value here, I'm going to close this window. Um, I had a result file called clearance data, and that's a CSV file. So if I go into my it saves it in documents. So here's the clearance data here, and so I can put a filter on that and sort it from smallest to largest, and I can see actually what the values are all the way up to 1. So those values there were the ones that were out of spec. But you can also see that if you look at the histogram, and the actual gives you the actual number. So anyway, I thought that was pretty cool because now we can take a parametric diagram where we have real numbers, and we can do some analysis on it.